All right, we're back working on polar, and this one we're going to go over derivatives in polar. I'm going to look at horizontal and vertical tangent lines. All right, so derivatives in polar. It's kind of similar to how we did derivatives in parametric. So remember, derivative is always dy dx, right? dy dx. It's the slope of the tangent line, the change in y over the change in x. Well, we don't have y or x. We have r and theta. So what we have to do is we need to get y as a function of theta and x as a function of theta. And we take the derivative of those guys. All right, well, we have formulas for that because we know that x equals r cosine of theta and y equals r sine of theta. So we're basically switching it over kind of to rectangular coordinates, but we're still using r and theta as our variables. So on the top, this was our y, r sine of theta. On the bottom, our cosine of theta, that's our x. So this is dy d theta, this is dx d theta. All right, so again, r is probably going to be something in terms of theta, and then we've got this extra sine of theta. And again, r is something in terms of theta times cosine of theta. So we have to do product rules. All right, so you can try and memorize this guy here if you want. I don't really suggest it. I usually just go back to these two guys, and I just remember those two guys and this part here, and that's enough to get me through. All right, so we get first times derivative of sine, which is cosine, plus the derivative of the r, which is dr d theta, times the sine. And on the bottom, we get the derivative of r times the cosine, and then we get r, derivative of cosine is negative sine, so we put that one second and say it's minus usually. But you don't have to. You can do it either way. So find the horizontal and vertical tangents of r equals sine of theta between 0 and pi. Okay, so if r equals sine of theta, that means y equals r sine of theta, and r is sine of theta. So we get sine of theta times sine of theta, which is sine of theta squared, which I can write like that, or I can write that squared up there. My x is r cosine of theta, which is going to be, in this case, since r is sine, it's going to be sine of theta times cosine of theta. All right, don't really have any way to simplify sine and cosine. Well, I mean, there are some, but I'm just going to leave it like that. All right, so now I want to take the derivative. So I want the derivative of y on top. So dy d theta would be derivative of this guy, which is chain rule. So we get 2 sine of theta to the first times derivative of sine of theta, which is cosine of theta. All right, so I didn't actually have to do all that. I just did the derivative of this thing right here instead. All right, for the next one, yeah, I definitely am going to have to do a chain rule, or sorry, a product rule. I did a chain rule for the top one already. So it's first sine of theta times derivative of cosine, which is negative sine of theta, plus second cosine of theta times derivative of sine of theta, which is another cosine of theta. All right, so on top, I've just got 2 sine theta cosine of theta. And on the bottom, I'm getting cosine squared theta minus sine squared theta. All right, so for horizontal tangents, the top will equal 0. So we'd get 2 sine of theta cosine of theta equals 0. For vertical tangents, the bottom's going to equal 0. And if both of them equal 0 at the same time, then it's kind of indeterminate. We'd have to do some other stuff there. So cosine squared minus sine squared equals 0. All right, so for this guy, this one's not so hard to solve. It's just we look at this curves for each one, and we can say when each one equals 0. Or we can use the trig identity that this is equal to the sine of 2 theta. And then we just say where does sine of 2 theta equal 0, which is just half of everywhere sine equals 0, which is all the integer multiples of pi. So this would be at 0, pi, 2 pi, 3 pi, etc. And then we would just divide them all by 2. Divide by 2, divide by 2, divide by 2, divide by 2. All right, now we only care about up to pi, so this is going to be too big. So this is going to be at 0, pi over 2, and pi. So that's where we're going to have horizontal tangents. All right, that'd be flat tangent lines that look like this. Vertical tangents, remember, straight up and down tangents, are when this guy equals 0. So this would be when cosine of theta equals or cosine squared theta equals sine squared theta. All right, and that's anytime sine or cosine are going to be equal to each other, positive or negative, because we'd square it and it would be positive no matter what. So that's going to be all of our pi over 4s, basically. Like pi over 4, 3 pi over 4, 5 pi over 4, and so on, right, when our triangles are the same. So let's take a look at the graph. There it is. All right, so it ends up, this guy, r equals sine of theta, is just a circle. Just a circle sitting here up on top of the, what's usually our x-axis, with a radius, or with a diameter, looks like, of 1, so radius of a half. And at 0, 0, we've got our horizontal tangent. At 1 pi over 2, yep, pi over 2, we've got a vertical tangent. We probably do want to find points, so we'd probably want to plug all these in to find points. Whenever they say to find vertical and horizontal tangent lines, we'd find points or equations of the lines. All right, same with this guy and this guy, the pi over 4s from down here. All right. Another one, a little tougher this time. So we've got want to find the horizontal and vertical tangents of this guy. All right, so that means y equals r sine of theta, and r is this guy. So we'd get 2 times 1 minus cosine of theta times sine of theta. So that means dy d theta would equal derivative of this guy. Well, I'm just going to leave the 2 with this. I'm going to say it's this times that and do a product rule. So first, 2 times 1 minus cosine of theta times derivative of the second, cosine, plus the second, sine, times derivative of the first. Well, the 2 is going to still be there. Derivative of the inside, the 1 goes away. I've got a negative. Derivative of cosine is negative sine, so that's going to change it to positive, and I get sine. All right, so if we simplify this guy, let's see, we're getting 2 cosine. Just 2 times each of those, then times cosine. So 2 cosine of theta. Then this is going to be minus 2 cosine squared theta plus, and this is going to be 2 sine squared theta. And we want to know, where does that equal 0? Not so easy to solve that. We would probably have to graph that to solve that. There's a little bit of simplifying that we can do, but we're still going to have some cosines left over. Maybe we could change this to 1 minus cosine squared to get everybody to be cosine, just using Pythagorean identities, and then maybe simplify some more. So if we do that, we'll have 2 cosines minus 2 cosine squared plus 2 minus 2 cosine squared equals 0. So it looks like we're getting negative 4 cosine squared plus 2 cosine theta plus 2 equals to 0. We can take out a negative 2 from everybody. 2 cosine squared plus cosine plus 1 equals 0. And then we can try and factor that. We could treat this like 2x plus x plus 1. So it'd be 2x and 2x. I cancel out one of those 2's later. 2 times 1 is 2. Factors of 2 that add to make 1. I need one of these to be a minus. Oh, both of these should have been minuses. That makes our life a little easier. There we go. Minus, minus. Took out a negative sign. Forgot about that. Big difference. So minus and plus, factors of 2 that subtract to make 1 are 2 and 1. So this we can cancel out the 2. X minus 1, 2x plus 1. That's just me factoring here. So I get negative 2, and instead of x, I've got cosine. So we get cosine of theta minus 1, and 2 cosine of theta plus 1 equals to 0. So this one, I'm getting where cosine of theta equals 1, which is at 0, and then again at 2 pi. So 0 and 2 pi is what theta equals for that guy. For this one, we'll end up with cosine of theta equals negative 1/2, which happens there and there. So it's in the, let's see, that's the second quadrant and the third quadrant. All right, we need, let's see, the adjacent to be negative 1, hypotenuse is 2, then this would be the square root of 3, negative 1, second quadrant, not fourth quadrant. I was looking at this and thinking there, negative 1 root 3 and 2. So this is going to be pi over 3 here. So that'd be 2 pi over 3 and 4 pi over 3. All right, so those are all of our horizontal tangents. All right, those are the theta values. We'd actually have to plug them back into the original here to get our values to go with them, which you would probably want to do. So if we plug in 0 here, we get, so some of these are a good bit of work, just warning you. All right, so if we plug in 0 here for theta, I get the point, let's see, cosine of 0 is 1, 1 minus 1 is 0, so I get the point 0, 0. If I plug in 2 pi, I'm back around there again. So let's see, if I do 2 pi over 3, there's my theta. What's r going to be? So 2 pi over 3, cosine of 2 pi over 3 is negative 1/2. So I'm going to get plus 1/2 here. So 3/2 times 2 is just going to be 3. And it's going to be the same thing for 4 pi over 3. Because we get the same cosine value. All right, so there's our horizontal tangents. Now to find the vertical tangents, I don't know if I have room because the graph's going to come in here in a minute. All right, but to find our vertical tangents, we're going to find, we're going to say, okay, x equals our cosine of theta. So then, which would be, let's see, we're going to plug in for r that. So x is going to be 2 times 1 minus cosine of theta times another cosine of theta. All right, if we want to simplify first, we can do that as well. I'll show you a different way. So this would be minus 2 cosine squared theta. And then we take the derivative, dx d theta, not d theta, there we go, dx d theta. So the derivative of 2 cosine is negative 2 sine. Minus, and let's see, you got to do this as a chain rule, like cosine of theta squared. So we'll get 4 cosine of theta times root of the inside, which is a negative sine of theta. So these negatives are going to cancel out. And we're going to get minus 2 sine of theta plus 4 cosine of theta sine of theta. All right, now I can factor out a sine, and actually I can factor out a negative 2 as well. So if I pull out a negative 2 sine of theta, I'm left with 1 minus 2 cosine of theta. And I want to set that equal to 0 to find the vertical tangents. All right, so that'll happen when sine equals 0. So we're going to get, oh gosh, 0 and pi and 2 pi and so on. And then this other guy is going to happen when cosine of theta equals 1/2. All right, which happens at positive in the first quadrant at pi over 3, and in the fourth quadrant at, let's see, 5 pi over 3. How does that end up looking on the graph? Yep, there's our 5 pi over 3. There's our pi over 3. Those are our verticals. There's our pi. Yep. Not those ones, because those ones, the top also equaled 0. Here's our 4 pi over 3. So we want to throw this one out too, because the bottom and the top both equaled 0 there. So we're throwing both of those out. And yeah, we have something weird happens at 0 and 2 pi. And let's see, we've got the 2 pi, or the 3 2 pi over 3, that's this one. And the 3 4 pi over 3, that's that one down there. Yep, those are definitely the horizontal ones. Wish I could have moved this graph down a little bit farther, and there's our vertical ones there and there. So again, we need to plug in these guys to get points out of them back into the original guy here, but that would give us our answers. And I'm going a little long, so that's it for that one. Again, problems get a little long here sometimes, I'm sorry, but that is how we find horizontal and vertical tangents, or derivatives. If we want derivatives, we just divide those two answers, the dy d theta and dx d theta.